We're recording. Okay. Is it a function? So for this nature, it's a function. But now, because this one is a directorial sheet, there was a dot here. There were 1, 2, 3, 4, 5 dots. So one dot is not going anywhere. Is this still a function?
No.
So not a function. Because one element of the domain is not related to an element of the image. So I've also given a reason why we feel it's not a function. The third one, we have so the third one, that dot, this dot, and another one going to dots of this nature. These two goes to 1, and this one goes there. Is it a function?
No.
No, that's not the function.
Why?
Because
Because one element of the
It's actually
domain.
a function.
This is a main-to-one function.
But one element is being made.
But one element, yes.
Yeah, but we don't
Aside
care
from the
about
domain.
the image. We care much
Okay.
about the domain.
Okay.
Because even in the definition we said a function
Domain.
is a rule that maps each element of the domain to a unique element of the image. So the concentration is on the domain. It must be uniquely related like that. Okay, we go to the fourth one. The fourth one, we have 3 dots and 2 of them going to 1. The other is not going anywhere. Is it a function?
No, it's
No.
not.
Not a function. Good. And the fifth one, we have 1, 2, 3, 4. All of them going to nowhere. Is it a function?
Yeah.
No, it's not a function.
Not a function. Because how do they go to nowhere?
Oh,
Mhm. And then the other one is going to be from there, here, and then 1, 2, 3. These 2 goes to 1. This one goes to its own. Is it a function?
Yes.
So it's
Yes, it's a function.
Okay. So we have checked which ones are functions and we've said which ones are one-to-one and not one. Wherever we found a one-to-one, we mentioned, is it? It was only one that had one-to-one. The other ones were meant to one, those that became functions. Okay, so this was question 1A. We want to do, so 1A stroke B, so that we go to 1C and explain some nice concepts here. C, you are given F and G are defined as follows. F of X is equal to 2X, 0 less or equal to X less than 3, less or equal to 3, and then X squared 3 less or equal to X less or equal to 6. And G of X 3X 0 less or equal to X less or equal to 3, X squared 3 less or equal to X less or equal to 6. The question says, explain why G is a function but F is not. So explain why G is a function but F is not. So let us give an explanation. How do we explain? So let's target 3. Since F has 3 here included, it has 3 here included. In the same F, F of 3 must be the same number. So let's start in the F of 3 that is on top there. We'll get 2 by 3, which is 6. In the same F, you substitute 3 down, you get 3 squared, which is equal to 9. This means that if we were to form this, we would put 3 here on the left, and we'll have 6 and 9 there, giving us 6, the same 3, giving us 9. So F is not a function because it is a one-to-many relation. That's how you justify. The same number 3 has given us 2 values. That's the reason why F is not a function. Now let's see G. For G, the same 3, you substitute on the top one there, we get 9. In the same G down, 3 squared gives us 9. So if you try to form this, you would have 3 only there and going to only 9. So G is a function.
Sir,
Hello.
since a one-to-many is not a function, so a many-to-one is a function.
A many-to-one is a function, but a one-to-many is not a function because of this definition here. A function is a rule that maps each element of the domain to a unique element of the image.
Oh, okay. Thank you.
Yes. So this is what I've disqualified F and qualified G. Okay. So let's go to question 2 and see what's there. Question 2A, if G of X is equal to X squared minus 6, find G of 4. G of 4 will be 4 squared minus 6, which is 16 minus 6, which is 10. You just substitute where there is X in G, you take 4. 2, find G of negative 4. That will be negative 4 squared minus 6, giving us 16 minus 6, which is equal to 10. Mm-hmm. 3, find G of 2. G of 2 is 2 squared minus 6, which is 4 minus 6, which is negative 2. The next question here is 4. Find the possible values of A if G of A is equal to A. So G of A is equal to A, meaning, so we'll go in G of A, G of X to form G of A. So G of A is going to be A squared minus 6. Now we are told G of A should be equal to A. So say A squared minus 6 is equal to A. This is the same as A squared minus A minus 6 is equal to 0. This is a question which troubled us the most in the test, where we are asked to find the values of X, where G inverse of X is the same as G of X. It's the same setup. So you get the product here, it will be negative 6, the sum is negative 1. So the factors becomes negative 3 and 2. So that we have A squared minus 3A plus 2A minus 6 is 0. So that we get A minus 3 plus 2A minus 3 is equal to 0. So A minus 3 multiplied by A plus 2 is equal to 0. A is equal to 3 or A is equal to negative 2. So these are the possible values of A for which the condition asked in the question is satisfied.
So what's the question again for this question?
It's saying find the possible values of A if G of A is equal to A.
Oh, so
Yes,
number
so
one,
find
the
A if this is equal to A.
which of the equations do we get? So we get G of X is the one that equates to the A.
Yes.
Then what does the 4 go? Or what does X you put? Okay, I've seen. What does X you put?
A.
Oh, I think.
Okay. Then let's go to B. To B, we are told if f of x is equal to 2x plus 1, find f of x squared. So let's call it 1. Find f of x squared. This is going to be f of x squared, which is, in fact, we are done even here. Or if you want, you can choose to expand 2x plus 1 multiplied by 2x plus 1. So it becomes 4x squared plus 2x plus 2x plus 1, which is 4x squared plus 4x plus 1. Like that. Then we're also asked to find f of x squared. This means in f of x, where there is x, we take x squared plus 1. That's all. The last piece, find f of x. Meaning, where there is x in f, take the whole f. So it will be 4x plus 2 plus 1, which will be 4x plus 3. Okay. Let's now go to the third question. So these are the properties of functions that Mr. Hancock wants us to know. When you're preparing for the exam, the first two in your hands is having the notes. The second, having all the solutions to the tutorial questions. Then use those to practice now in answering the exam papers, just to see how they phrase things around. But what you must know, the key thing is you must have the notes well understood, and then the tutorial sheets well understood. In fact, if you understand the tutorial sheets in whichever way, even if you didn't understand all the notes, it's a must that you're going to clear the exam. So question 3, A, the function g is given as g of x is equal to ax squared minus b. If g of 2 is equal to 5 and g of -1 is equal to 2, find a and b, and hence g of -4. G of -4. So the function g is given. If g of 2, so now as you are solving this, you follow the language. G of 2, meaning you must know what g of 2 is. G of 2 is a 2 squared minus b. This is 4a minus b. G of -1 is a -1 squared minus b, which is a minus b. Now we are told if g of 2 is equal to 5, meaning 4a minus b is equal to 5, or g of -1 is equal to 2, meaning a minus b is equal to 2. Like that, find a and b. So you solve simultaneously. If we add, we'll have 5a. No, you can't add. If we subtract using elimination method, if we subtract, we'll have 4a minus a, we'll get 3a. And then -b minus b, that will be 0. Then 5 minus 2, we get 3. Divide by 3, divide by 3. So we have a is equal to 1. Then we go back and get b. So a minus b is equal to 2. If a is 1, what will be b? It will be 2 minus 1. So negative b is 1. So b is negative 1. Therefore, a is 1, b is negative 1. The next thing is find g of negative 4. Now that you have the values of a and b, our g of x has become x squared minus 1, which is x squared plus 1. So what is g of negative 4? That is negative 4 squared plus 1. That is 16 plus 1, which is 17. And that's how we obtain that. Okay. Now we go to B. Find the range of each function for the given domain and state whether the function is one-to-one. So that is B. You find the range of each function for a given domain and state whether the function is one-to-one. 1, f of x is equal to x minus 2. The domain given is x, such that negative 2 is less or equal to x, less or equal to 4. So I want to find the range of this function given the domain. So you substitute the smallest number, negative 2. So what is f of negative 2? It will be negative 2 minus 2, which is negative 4. Substitute also the biggest number, 4. You get 4 minus 2, which is equal to 2. Automatically, the range now here becomes from 2 all the way up, from negative 4, from negative 4 all the way up to 2, both included. That is the range for the given domain, not just any range. Two, we are given f of x, and then state whether it's a one-to-one. Of course, this one is a one-to-one function, and state whether the function is a one-to-one. So how do we define a one-to-one function? So a function f of x is said to be a one.
Sir,
Hello?
I'm sorry. How did you find the range? I missed the point.
So we're saying find the range of this function on a specific domain. The domain given is here. Not on an open R, but on this given domain. Meaning, you take the smallest number in the domain, substitute in the function, take the biggest number in the domain, substitute in the function. The values you get, the smallest value bounds the range, the biggest value bounds on the right. And that's how you obtain the range.
All right, thank you.
Okay. So a function is said to be a one-to-one function if f of x is equal to f of y implies x is equal to y. What do we mean? Let's solve to determine if one is a one-to-one function. So f of x is equal to x minus 2. F of y is equal to y minus 2. Now, if x minus 2 is equal to y minus 2, let's solve and see if this will mean that x is equal to y. So we take to the other side, we have x is equal to y minus 2 plus 2. X is equal to y. Since we started with f of x is equal to f of y and ended with x is equal to y, it means that f of x is a one-to-one function. That's how you check. Okay. Let's go to 2. 2, f of x is equal to x squared. The domain given is x such that -3 is less or equal to x less or equal to 3. Again, we pick f of -3. -3 squared is equal to 9. Pick f of 3. 3 squared is equal to 9. They are giving us the same number, meaning we must go for the middle number. Since 0 is part of this interval, we need to go for 0 and see what we get. This will be 0 squared is equal to 0. This means that the range runs from 0 all the way up to 9 for that interval. Is it a one-to-one? Let's see. F of x is known as x squared. F of y will then be y squared. If x squared is equal to y squared, this will mean x is equal to plus or minus y, not a one-to-one. Because the same x value gives us positive y and minus y. So it can be a one-to-one function. Let's see the fourth one, the third one. So it was written as the fourth, okay. 1 over x minus 1. The domain given is x, such that x is not equal to 1, but x is a real number. What is the range? So to get the range of such type of a function where the domain is every real number apart from where the function fails to be defined, we solve for the inverse. That is yx minus y is equal to 1. So yx is equal to 1 plus y divided by y. So x is equal to 1 plus y over y. So our range is going to be y such that y is not equal to 0, but y is a real number. So this time around, our domain is not just a small unit. Our domain is the whole real line except at 1 where the function fails to be defined. So it becomes a normal function now, just like any other function that we've been doing before this. Then now you must check if this is a one-to-one. So you say f of x is equal to f of y. This implies 1 over x minus 1 is equal to 1 over y minus 1. Cross multiply, y minus 1 is x minus 1. So you have y is equal to x minus 1 plus 1 implying that y is equal to x, hence a 1-to-1. That's how we get to know. Okay. The last one is the fifth one. F of x is equal to 1 over x squared plus 1. The domain is OREO. So what will be the range? So the range here is going to be from 0 all the way up to so we need to solve this one, but okay, it's not possible that we can solve it now because we just have less than a minute in the Zoom plan. We may fail to save this. Okay, I've saved. So we can't log out and log back because of the time remaining. We have another class at 18. So what we'll do is we've gone as far as question 3, 4. So question 3, 5, that's what we're going to start from. And then finish this in the next class. And then start looking at computing the square and some other properties of functions. When we feel we are done with the concept of the tutorial sheet, we'll go to the tutorial sheet and have it answered. Please keep these answers somewhere where I don't lose them. You need a book for the tutorial sheets for mathematics, so that when it is November, we start doing pure revisions of what you have understood. You don't start looking everywhere searching for answers. You already have the answers. Your target is just to understand them. So see you tomorrow. Oh, I don't know how the timetable is.
Yes, we meet tomorrow.
Okay, so tomorrow.
Thank you, sir.
Okay.
Thank you, sir.
Okay.
Thank you, sir.